Hey Chem Kids, Campbell here. In this video, we're going to talk about how to balance simple oxidation and reduction reactions. Now you're probably wondering why? What's different about balancing oxidation reduction reactions from what we've already done? Well, in an oxidation reduction reaction, not only are we having to balance atoms like we've done before, but because electrons are moving, that means the charge is changing, and we also have to balance charge. So we're going to balance atoms just like before. And now we're also going to have to balance the charge. So let's take a look at an oxidation reduction reaction, a simple one. Here we have tin plus 2 plus iron yields iron plus tin plus 4. So is this reaction balanced? Well, first let's look at the number of atoms. So here I just have one tin atom, and over here I have one tin atom. How do I know it's just one? Because there's no subscript. That charge is just simply the charge, not how many there are. So for example, if I had oxygen and I had a subscript of 2, that would mean that I have 2 oxygens. But in these cases, I only have 1, so the atoms are balanced. Here I have 1 iron and I have another 1 iron, so iron's balanced. Cool. Now let's look at the charge. So that's that little plus or minus that you'll see up at the top. So here, this tin is plus 2. This iron is a plus 2. So when I add my total charge together on this side, I get a plus 4. So that means that on the other side of the reaction, there also has to be a total charge of plus 4 because charge has to also balance. So if there's nothing up here, that means that actually that charge is 0. And here that tin is a plus 4, right? That's plus 4. So 0 plus 4, right, is a total of plus 4. So in this case, both the atoms and the charge are balanced. All right. But what if they're not? Well, let's go through all the steps for balancing the reactions. So let's look at the steps for balancing reactions. The first thing we're going to do is we're going to separate the reactions into half reactions. Half reaction? What's a half reaction? What we're going to do is we're going to put the stuff into their own reaction. So we're going to take the tin out and make a reaction with it, and we're going to take the iron out, and we're going to put it in its own reaction. You'll see what that means on the next slide. Then, just like any other reaction, we're going to balance the number of atoms if necessary. That won't always be necessary. Step 3 is always going to be necessary. We're going to balance charge by adding electrons to the appropriate side of the half reaction so that each half reaction has a balanced charge on the reactant and product side. Now remember that electrons are negative, so a little hint here is you're always going to add the electrons, that's a little symbol I use for electrons, to the side of the reaction, the side of that half reaction that is the most positive. At this point, because we have our electrons added to either the reactant side or the product side, we are then going to identify which half reaction is the oxidation, which half reaction is the reduction. Lose electrons oxidize, so the ones within the product side is an oxidation. Gain electrons, the reactant side, that's going to be the reduction. You're going to have to do that in your homework and on the test, so we might as well do it at this point in our little balancing stage. The next thing we're going to do is we have to check to see if the number of electrons in each half reaction are the same. They have to be the same because whatever one thing is giving has to equal the same amount of electrons the other one is gaining. You can't give different amounts than you get. So we're going to have to multiply by a number that is a common factor so that the number of electrons that are being given are the same as the number of electrons that are being gained. This is because when we put our half reactions back together into a complete reaction, we have to be able to cancel out the electrons. So if you remember back to the kinetics unit, when we wrote the overall reaction, remember we had like the intermediates would be a product in an early reaction and a reactant in the later reaction. So they were on opposite sides of the arrow, and they cancel when you write the overall reaction. We're going to do the same thing with the electrons. So in order to do that, they have to be the same in each reaction. So let's actually do one. Here we have our chromium plus 3 plus zinc yields chromium plus zinc plus 2. So we're going to write a half reaction. We're going to do that by writing the chromiums together. So we're going to do Cr plus 3. And then I like to leave some space in case I need to add the electrons. I like to put them after the element, but you could put them before, it's fine. And then we're also going to do that with the zinc. So here's our zinc, and then we put our arrow, and then we're going to have our zinc plus 2. All right, so those are our half reactions, step 1. Step 2, we're going to check to see if the atoms are balanced, and if they're not, we'll add coefficients just like we always did. Well, I only have 1 chromium here and 1 here, so that's balanced. And same thing with zinc. There's only 1 on each side. The charge, that has to do with the electrons, not with the number of atoms. So none of these have subscripts, so I don't have to worry about putting numbers in front. Step 3, charge. Well, if I look in this first half reaction, this is a plus 3. And if there's nothing up here, that means the charge is 0. So these are not balanced for charge. So that means I need to add electrons to the side that's most positive. So that's like subtracting. So I'm going to add it to the plus 3 side. And so if adding electrons is like subtracting, I need to add 3 electrons because each electron has a charge of -1. So that would be like adding a -3, right? If I do that, then this charge on this side is 0, which matches the chromium side. If I go down to my next half reaction, I can see that I have a zinc that has a charge of 0 on this side, and this side is plus 2. So in order to make these equal, I add electrons to the side that's most positive, which is my zinc plus 2. So I'm going to add 2 electrons to this side, because that's like subtracting 2. So plus 2 minus 2, right, that equals 0. And so now both of the sides of both of my half reactions are balanced. So now at this point, we might as well identify who's oxidation and who's reduction. Well, remember, oxidation is LEO, lose electrons. So this means I'm losing electrons. I'm giving them away. So this is the oxidation. Here, gain electrons. I'm gaining electrons here, so this is the reduction. That doesn't have anything to do with balancing, but you're going to have to do it. So this is a great time to do that. Next, what we have to do is step 4. You'll notice that in the first reaction, I have 3 electrons, but in the second reaction, I have 2. So I can't put them together right now because the number of electrons has to be the same. So what is the smallest number that both 3 and 2 go into? Well, that would be 6, right? So if I multiply everything in this reaction, what you have to do to one side, you do the other, multiply that by 2, and I multiply this one by 3, then I'll have 6 electrons in both reactions. So let's do that. So that means I'm going to have 2Cr plus 3. 2 times 3 is 6, so that's 6 electrons. 2 times 1, right, there's our arrow, 2 chromiums. We'll do the same thing with zinc. So that means we have 3 Zn, arrow, 3 Zn plus 2, plus 3 times 2 is 6 electrons. All right, so now I have 6 electrons here, 6 electrons here, so we can put them all together. So the stuff on the left side goes together. So we're going to do 2Cr plus 3 plus 3 zinc. Now that's all there together. I go to the arrow, and we go 2Cr plus 3 Zn plus 2. Now, I like to just check to make sure that the atoms and the charge are balanced. So I'll go back and look just to make sure I didn't mess up. And I see I have 2Cr here, 2Cr here. Good. 3 zinc, yes. I look at the charge, and when we do the charge, we have to multiply by the coefficient, because this means I have 2 chromiums at plus 3. So that's 2 times plus 3, right? That's a total of plus 6. Here is 0, so 3 times 0, right? That's just 0. So my total charge on this side is plus 6. That means my total charge on the other side also has to be plus 6. So here, this is 2 times 0, so that's just 0. And here, this is 3 times plus 2, so that is plus 6. So they're both the same on both sides from an atom and a charge perspective. So that means that this is my final answer. All right, let's do another one. Here is one where I have iodine plus potassium yields potassium plus 1 plus iodine minus 1. So let's write our reaction into half reactions. I2 yields I minus 1. And then we have our potassium and potassium plus 1. So that's step 1, half reactions. Balance atoms. So in this one, you can see that iodine has a 2 here, and I only have 1 here. So that means I have to put the number in front. Don't try to put a subscript on. You can only put the coefficient. So now that's balanced. And here for potassium, potassium, one of each looks good. Step 3, electrons. This side has no charge, so that's 0. This side, right, this is 2 times -1. So that's a total of -2. So I have to add electrons to the side that's most positive. That would be the side with 0, right? So I'm going to add 2 electrons to this side because that's like just adding a -2. So now both sides have a -2. For potassium, this charge is 0, and there's only 1 plus 1 here. So this is the more positive side. So we're going to add 1 electron here, right? That's like subtracting 1. So that side is 0 now as well. So now both sides have the same charge in both half reactions. Let's identify who's oxidation, who's reduction. Here I'm gaining electrons, so this is reduction. Here I'm losing electrons, that's oxidation. It is just a coincidence that they are in the same order they were in the last problem. That's normally not how it goes, or don't assume that. Step 4, I have 2 electrons here. I only have 1 here. So fortunately, 1 goes into 2, right? All I got to do is multiply this by 2. I don't have to multiply the first one. But I'm going to rewrite the first one just so they're together. So I2 plus 2 electrons yields 2I minus 1. This one I have to multiply through, so I have 2K, arrow, 2K plus 1 plus 2 electrons. So now my electrons are equal, and I can cancel them out. And then I put them together. Everything on the left side goes together. So I2 plus 2K, arrow, 2I minus 1 plus 2K plus 1. And then I like to check 2I, 2I, 2K, 2K. Total charge here, right? Those are both 0, so that's 0. Almost looks like a weird face. Here we have 2 times -1, right? So that's a total -2. Here I have 2 times +1, so that's a +2. So once again, that side 0. Whew! Atoms, charges balanced. Check. Done. All right, we're going to do one more, but actually, I want you to try this one. See if you can balance this one. Pause the video, and then see if you got it right. So if you did this right, you realize that nickel was the oxidation reaction and copper was the reduction reaction. And when you put them together, you should have a final that says nickel plus 2 copper plus 1 yields nickel plus 2 plus 2 copper. And again, always check. I have 1 nickel, 2 copper, 2 copper. Here, the total charge is, this is 0. This is 2 times +1 or a +2. That means this side has to be +2. And if I look, that is the case. This is +2. So if you got that, you did it right. How'd you do? Work on some of the practice problems. And if you need some help, come to office hours. It'd be great to see you.